This is a short overview of my work and how I understand artificial intelligence from a practical systems perspective. This wiki documents my hands-on work building AI systems step by step, from drones to language models to robotic intelligence. The structure, concepts were organized by me with the help from ChatGPT to focus on clarity rather than hype. There's one core idea behind everything. The most important AI concept, in my opinion, is a UFA, Universal Function Approximator. The UFA is the source of the I intelligence in AI. A transformer neural network inside an LLM is a UFA. So you can input a set of tokens that this UFA has never seen before, and it will still produce a correct response, usually. However, this power comes from probability, approximation, statistics, and that means it can sometimes fail. And what experts sometimes call a hallucination. Deterministic functions don't fail in this way, but they're limited. And in the diagrams on this wiki, the light bulb icon marks where so-called intelligence occurs, either from a deterministic function on a CPU or from a UFA neural network on a GPU. So AI drones, phase one. I began by building AI drones using CNN-based object recognition. CNN is convolution neural network. The system had two main parts. It had the drone platform with the camera, flight controller, sensors, motor control, forming a deterministic sensing and control layer. A Jetson nano computer. So this provided the GPU to run neural network models on board. And then object tracking. This used deterministic math, geometry, Kalman-style estimation. The neural network handled the object recognition from the camera. This last part here. The second phase was large language models. I built local, remote models, fine-tuned systems, custom interfaces, agents, RAG pipelines. An LLM has three main components, three core parts. The external agent, that it's a deterministic program that prepares inputs and calls the model. An internal agent, this is 2.2, it manages conversation history and prompt structure, and transformer neural network, 2.3. So this is a UFA that maps input tokens to output tokens. Now this phase, phase two, showed how neural networks can model complex relationships far beyond explicit programming. We have robotic AI. That's my current focus. Unlike drones, close-range robots, they operate in unforgiving environments where errors cannot be tolerated. So this requires what they call belief and world modeling under uncertainty. So the system includes the following. Robotic control agent forms a closed loop of perceive, predict, decide, and act. And the perception perception models, like CNNs and VITs, the video transformers, for extracting features from sensors. Then the deterministic world state. Now that is geometry tracking, Kalman-style estimation, occlusion when something is hidden, and persistence, providing a stable internal belief. Then neural assist, neural networks that refine the deterministic state by estimating uncertainty and correcting errors. Then the JEPA model, this most interesting part, enabling internal simulation of actions, allowing the system to predict outcomes and plan before acting. This phase focuses on the core algorithms required for reliable autonomous behavior. So the project so far has been a good foundation for future work. The planned directions include my planned directions in the future: formal robotics and AI study, writing books based on the lab notes. There are a very large number of lab notes. Creating educational videos, like this video, and publishing structured research through blogs and Substack. And that's it. So this wiki is my attempt to understand AI through real systems, not hype. As I said before, I've done a lot of these demos, and the lab notes for all the demos are listed on my Google Drive. So if you're interested you're interested in AI from a practical systems perspective, the demos and the notes here may be useful. Thanks for watching.